show directly from the definition that this function is neither odd nor even. Well, this is something we've done a few times, really. It's something where all we've got to do is check that it messes up in some way. There are kind of two ways to do this, one which isn't rigorous, one which is. You could just graph it and show it doesn't have the appropriate symmetries. Right? So the appropriate symmetries would be for even reflective symmetry when I reflect in the y-axis, or odd rotational symmetry when I rotate around the origin by 180 degrees. If the graph doesn't have symmetry for both of those, it's neither odd nor even. But I think we should be able to do this directly algebraically. So remember what it means to be odd or even. I mean, basically what you need is the following. We need f of x. So let me just put it. So odd or even, what does that correspond to? For a general function, it means f of minus x is equal to either minus f of x or f of x. It's the meaning of odd or even, and this is for all x in the domain, not just some x, it will be for everything. That's what we need. If it fails anywhere, if there's a single value of x where it doesn't work, it's over. So what's the simplest examples? Let's just feed in 1 and minus 1, shall we? So if I have f of x is equal to 3 over 5x, this would imply, well, let's just do f of minus 1. That's equal to 3 over 5 to the minus 1. You can write that in various ways. I mean, we could take the reciprocal. Remember, the meaning of this is 1 divided by 3 over 5, and that just turns everything upside down, so that's 5 over 3. And then f of 1, of course, is 3 over 5 to the power 1, but that's just 3 over 5. And together, what do I see? Well, it's not the case, right? I don't have it. This is not equal to either plus or minus f of 1. So we are not odd or even, so neither. Because there's a failure once. It might work somewhere. Right? It's always going to work, for example, x is equal to 0, but it's not going to work anywhere else. So at the moment there's a single failure, it's done.